Now the next topic that we will discuss is family of lines through the intersection of two lines. First we'll write the statement, then we'll understand. This says the equation of family of straight lines passing through the intersection of the lines a1x b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0 is given by a1x plus b1y plus c1 plus lambda times a2x plus b2y plus c2 equals to 0, where lambda is a parameter. Now what does this say? Suppose we have two lines and they are intersecting, and let's say this line is a1x plus b1y plus c1 equals to 0 and this is a2x plus b2y plus c2 equals to 0. Let the point of intersection be alpha comma beta. Now the statement says we need the equation of line which is passing through these two lines. There would be how many lines? There will be infinite lines that will be passing through this point. That is why we are calling it family of lines, because all the members of this family are passing through this point. There will be infinite lines. All these lines will have a common characteristic that they all are passing through alpha beta. That is, alpha beta will be satisfying all those equations. For different values of lambda, we will have different members of the family. For example, if lambda is equal to lambda 1, we'll get this member of the family. For lambda 2, we'll get this. For different values of lambda, we'll get the different members of this family. And why are we calling this a family of straight lines? Because all the members of this family are passing through alpha beta. When we say a family, we have something in common. So what is the common thing in all those lines? In all these lines which are passing through this, all these lines are passing through the point of intersection of these two lines. And since point of intersection is a unique point, therefore all these lines will be satisfied by alpha beta. And for different values of lambda, we will get different members of this family. Let's say this is line L1, this is line L2, this is L3, L4. These are members of the family. And which family? The family of lines which are passing through alpha beta. Now how did we come to this conclusion that this represents such lines? Now since alpha beta satisfies these two equations, we can write a1 alpha plus b1 beta plus c1 is 0, because alpha beta will satisfy not only the first equation but also the second equation. A2 alpha b2 beta plus c2 is 0. Now first of all, if we assume this to be true, then we can write a1 x plus b1 y plus c1 plus a2 lambda x plus b2 lambda y plus c2 lambda equals to 0. Now if we take the like terms together, a1 plus a2 lambda, y is b1 plus b2 lambda, and c1 plus lambda or c2 lambda is 0. Now a1, a2, b1, b2, c1, c2 and lambda are all constants. a1, b1, a2, b2, c1, c2, lambda are all constants. Therefore we find that this is what? This is a linear equation. This is a linear equation in x and y. And all the linear equations in x and y represent what? They represent straight lines. Therefore this equation is definitely representing a straight line. But how do we come to the conclusion that this is passing through alpha beta? Why? Now if this is the equation, a1, if alpha beta, if this line or this family of line is passing through alpha beta, it should satisfy this equation. So a1 alpha plus b1 beta plus c1 plus lambda times a2 alpha plus b2 beta plus c2, we find that this should come out to be 0. But we have already seen that alpha beta satisfy this equation and this equation. Therefore a1 alpha plus b1 beta plus c1 is 0. and a2 alpha plus b2 beta plus c2 is also 0. Therefore this is definitely coming out to be 0. Therefore the equation that we have considered is definitely passing through alpha beta because it is satisfying this equation. Therefore combining the two, this equation is passing through the point of intersection of the two lines, point of intersection of the given two lines, Why? Because this equation is satisfying the point of intersection, that is alpha beta. It is satisfying those points. It means this line is passing through alpha beta. And what is alpha beta? It is the point of intersection of two lines. Therefore combining both the conditions, first and second, it is definitely a straight line and it is also passing through the point of intersection of these two lines. Therefore what we have considered or assumed is absolutely right. This is definitely representing family of lines which is passing through intersection of two lines. And for different values of lambda we can find different members of the family. How will we find lambda? Lambda will be found out. Lambda is found by the extra condition given in the question. Extra condition given in the question. One thing we should note, there is a note, we can get all the lines, we can obtain all the lines through the above equation except L2. That is, for no value of lambda we can obtain L2. We can obtain L1. L1 can be obtained, but L2 cannot be obtained for any value of lambda. L2 cannot be obtained for any lambda. Therefore, for example, if I say, let's take an example. We'll take a big example on this. Find the equation of the straight line which passes through the point of intersection of the lines x plus y plus 4 equals to 0 and 3x minus y minus 8 equals to 0. Now we stop at this point and we are given just this much information. We are not given any extra condition. We are just asked to find the equation of straight line which passes through the point of intersection of these two lines. Therefore, since our line is passing through the point of intersection, how can we write the form of our line? The form of our line will be what? X plus y plus 4. Bring all the terms of the first equation to one side, plus lambda times bring all the terms of the second equation of your equation of your line in one side and put it in this form. That is basically what we have learnt is, if L1 is the first equation and L2 is the second equation, L1 plus lambda L2 equals to 0. It represents what? Equation of line, equation of family of lines passing through the point of intersection of the lines L1 and L2. The only thing you have to keep in mind is bring all the terms of both the equations to one side and then put this in this formula. Now this lambda will be obtained by the extra condition that will be mentioned in the question. This will be obtained by extra condition. Now this represents family of lines which are passing through point of intersection of these two lines. The point of intersection will satisfy this equation. Okay. Now this can be written as, if we take the like terms together, 1 plus 3 lambda, y is equal to 1 plus, or rather 1 minus lambda, and the constant part is 4 minus 8 lambda. Now if you can look, this is a constant, this is a constant, this is a constant, therefore this is a linear equation in x and y, therefore it is representing a straight line. Moreover, this is definitely passing through the point of intersection of these two lines, therefore both these conditions are met. It is definitely a straight line and is passing through the point of intersection of these two lines.